In this last problem, we are asked to determine how much heat is required to convert 40 grams of ice at minus 10 degrees Celsius to steam at 120 degrees Celsius. To solve this problem, we will use Hess's law of constant heat summation as we did for the previous problem. And recall, if a process can occur in successive steps, then delta H for the overall process is equal to the sum of the enthalpy changes for the individual steps. So first, let's start by breaking down the overall process into individual steps. At initial conditions, we have ice, which is a solid, at minus 10 degrees Celsius. So this solid ice here will be heated gradually until it reaches 0 degrees Celsius, and it is still at solid shape. Now, at this level, solid will melt to form liquid water, and it is still at 0 degrees Celsius. Then this liquid water will be heated up until it reaches 100 degrees Celsius. And at this point, water will vaporize to form steam. And the vaporization is done at constant temperature, so still at 100 degrees Celsius. And finally, this steam is heated from 100 degrees Celsius to 120 degrees Celsius to get the steam in the final condition. Now, by applying Hess's law of constant heat summation, we can see that the delta H for the overall process, so going from this state here to this state here, is equal to the sum of the enthalpy changes for the individual steps. So the delta H for this step plus the delta H for this step here plus the one for this step here plus the delta H for this step here and plus the delta H for this step here. So to calculate the overall delta H of the process, we can calculate individually each delta H and then do the summation. So for the first case here, or the first step, this corresponds to the heating of a solid from minus 10 degrees Celsius to 0 degrees Celsius. The delta H heating corresponding to this step is equal to the heat capacity times the temperature change. So in our case, it will be equal to 0.2 kilocalorie. Now the second step represents the melting of ice, and the delta H for this process is equal to the heat of fusion times the mass of the solid ice, and this is equal to 3.2 kilocalorie. The third process corresponds to the heating of the liquid water from 0 degrees Celsius to 100 degrees Celsius. The heat corresponding to this process here can be calculated using the formula heat capacity times the temperature change. And in our case here, it is equal to 4 kilocalorie. The following step change corresponds to the vaporization of liquid water at 100 degrees Celsius. The delta H corresponding to this step change is equal to the heat of vaporization times the mass of the liquid water. And in our case here, this delta H vaporization is equal to 21.6 kilocalorie. And finally, the final step consists of heating the vapor or the steam from 100 degrees Celsius to 120 degrees Celsius. and the delta H for this step can be calculated by multiplying the heat capacity of steam by the temperature change. And in our case here, the delta H heating of the steam is equal to 0.4 kilocalorie. Now that we have the delta H or the enthalpy changes for each individual step, then by using Hess's law of constant heat summation, delta H for the overall process can be calculated easily by summing the individual delta H's. And in our case here, delta H for the overall process is equal to 29.4 kilocalorie.